So for starters, alkenes are hydrocarbons. And by now, I'm sure we are all familiar with what the term hydrocarbon means. So for those who have forgotten, hydrocarbon means the molecule contains carbon and hydrogen atoms only. It's a molecule that contains carbon and hydrogen atoms only. Secondly, their functional group. What tells us that when you see a particular molecule, what tells you that it's an alkene is within the structure, or when you look at a displayed formula, you expect to see a double bond between two carbon atoms. Within the molecule, you have to have a double bond somewhere within the displayed formula. So we look for a double bond. Number 3, all alkenes, their name ends with the suffix ene. So all alkenes end with the suffix ene. Number 4, their general formula that we use to find the formulas of all the existing alkenes, if we know what N is. So their general formula is given as CnH2n. Number 5, we say that they are unsaturated. They are unsaturated molecules. So the term unsaturated here means that they contain a double bond within the structure. Or we can look at saying that the term unsaturated means not all of the bonds, not all of the bonds present in the molecule, not all of the bonds between the carbon atoms, not all of the bonds are single bonds. Now, again, to say they're unsaturated molecules, it means the two carbons that are sharing the double bond, they have not reached the maximum number of atoms that they can be bonded to. So as a result of that unsaturation that is experienced by only the two carbon atoms sharing the double bond, we then say that alkenes, they undergo addition reactions. So our alkenes, they undergo addition reactions. So before we start looking at how the reactions look like, let's look at trying to come up with the formula. We want to come up with the formula and the displayed formula. We want to come up with the molecular formula, the displayed formula, and the structural formula of the first 5 alkenes. Now remember, the general formula that we're going to be using to substitute a value for N is CnH2n. Now, when N is equals to 1, molecular formula, we want to be able to come up with the name. We also want to be able to come up with the displayed as well as the structural formula. Right, so when N is equals to 1, substituting a value for N is equals to 1, In this formula, this becomes CH2. Such an alkene does not exist. The reason is, for you to have an alkene, you need 2 carbon atoms as a minimum so that they can share a double bond. When you have 1 carbon, the double bond cannot be between a carbon and a hydrogen. So there is no methane. Methane does not exist. So when it comes to these alkenes, we start off from when N is equals to 2. The formula then becomes C2H4, and our prefix is eth, so the name is going to be ethene. So if I'm going to try and draw the displayed, first draw the 2 carbon atoms next to each other, and these 2 carbon atoms present in ethene are the ones that are going to be sharing the double bond. Then put lines or bonds around the 2 carbons, ensuring that each carbon does not exceed 4 bonds. Then give each carbon hydrogen atoms. So that is how the 4 hydrogens are going to be distributed between the 2 carbons. When I write the structure of formula, the first carbon is joined to 2 hydrogens, so it's CH2. The second carbon is joined to 2 hydrogens, so that is CH2, CH2. That is my alkene ethene. When N is equals to 3, my formula is now going to become C3H6. I expect the prefix to be prop, so this is going to be called propene. How to come up with the displayed? Draw the 3 carbon atoms one after the other and place the double bond between any 2 carbon atoms in your chain. Put lines around the carbon, ensuring that you don't exceed 4 or you don't have less than 4 bonds around each carbon. Then, soon after, you distribute the hydrogens. And this, as a structure of formula, first carbon is a CH2 double bond. The second carbon is just joined to a hydrogen. And then you have a CH3. That is the next alkene, propene. When N is equals to 4, it's going to be C4H8. The prefix is but. So my number 4 is going to be referred to as butene. Draw your 4 carbons one after the other, joining them by single bonds. You only are expected to have 1 double bond only. So I'm putting it between the first and the second. We can put it on other positions, but the name will change. And we'll touch on that concept when I start talking about isomers. So this is my butene. Each carbon only has 4 bonds around it. That's the displayed formula where I've displayed all of the bonds. The first carbon, CH2, CH, CH2, CH3. That would be my butene. Right, when N is going to be equal to 5. That's the last one I'll touch on. C5H10. And the prefix is pent, so this one is going to be pentene. I draw the carbon atoms one after the other. I put my double bond between the first 2. I put bonds around each carbon to ensure it only has 4 bonds and it does not exceed those 4 bonds. So this becomes my displayed formula for pentene, which is C5H10. The structure of formula, CH2, CH, CH2, CH2, CH3. Right, I could go on, but these are just the first 4 alkenes that I wanted us to focus on. The next important thing now about alkenes is focusing on the reactions. Reactions of alkenes. Now, earlier on, I stated that alkenes, they undergo addition reactions. They undergo addition reactions because they are unsaturated. They undergo addition reactions because they are unsaturated. So we are going to fully understand what this term means as I start reacting my alkenes. So, of the reactions that they have, the first reaction I'm going to talk about is referred to as hydrogenation. We have a reaction known as hydrogenation. As the name suggests, there is the addition of hydrogen. So regardless of the example I use, you need to be aware that that particular reaction applies to all of the alkenes that we can come across. Any alkene that I can use, that reaction that I'm going to have, it applies to all of the alkenes. So I'm going to use ethene as my first example that's going to undergo hydrogenation. So my reagent is going to be ethene, and ethene is going to be reacting with hydrogen gas. For these two, for any alkene to react with hydrogen, there is a condition, or there are conditions that must be met. We need a catalyst. We can use nickel or we can use platinum as a catalyst, and we also need heat. So for any alkene to react with hydrogen gas, the conditions have to both be met. The presence of nickel catalyst as well as the presence of heat. And the product that we expect to end up having at the end of the reaction must be an alkene. Now, to illustrate how this reaction has happened, my hydrogen gas, this is H2, but I've decided to write them as separate atoms, still joined together. So what's going to happen is, of these 2 bonds that we have here, one of the bonds breaks. One of those 2 bonds is going to break. And when it breaks, what would then happen is each carbon that is sharing, each carbon that is part of the double bond is going to receive a single hydrogen atom. So I said the double bond breaks, and then each carbon would then create an extra bond on the side. Then the hydrogen atoms, one will come to that carbon, and the other hydrogen will come to the other carbon. And my final product here is ethane. I started off with ethene. Ethene underwent an addition reaction and received hydrogen, and it became ethane. Now, this reaction is important in industry, hydrogenation of alkenes. It's responsible for the formation of margarine from vegetable oils. That's reaction A. Reaction B, I'm going to refer to it as hydration. So as the name suggests, there is water that's involved in this reaction. So during hydration, our reagent is going to be steam. We want our water to be in the form of steam, and steam is going to react with an alkene. There are also conditions that are required for hydration to occur. We need a catalyst. In this case, concentrated phosphoric acid is going to be required. And apart from that, we also require heat. And the final product that we're going to form when this reaction happens is going to be an alcohol. I'm going to use a different alkene. This time I'm going to use propene. Prop meaning that I have 3 carbons. In meaning that I have a double bond somewhere between any 2 carbons. So this is where my double bond is going to be. Steam is water in the form of a gas. So when water is going to be added, please bear in mind the only 2 carbons that undergo the reaction are the 2 carbons that are sharing the double bond. So the water splits into an H and an OH. So I can decide to say my hydrogen is going to go on that first carbon. My OH is going to go on the second carbon. And the final product that I'm going to have everywhere else remains the same. The difference is only on the 2 carbons that were sharing the double bond only. One has received an OH and is the oxygen that will be bonded to the carbon. And the last one received a hydrogen. That is one possible product that can be formed. This is an alcohol. We'll learn about naming them under alcohols, but for now, this is called propane 2O. I can reverse who is going to be receiving the hydrogen and who's receiving the OH. I can reverse to say that it's the first carbon that can receive the OH and it's the second carbon that can receive the hydrogen. And the final product that I'll be having and again, this is an alcohol and it's going to be called propane 2O. So, sorry, not propane 2O, but this is going to be called propane 1O. I said the naming of what is involved here, it's something that we'll do under alcohols. So these are 2 possible products that can be formed when propene reacts with steam in the presence of concentrated phosphoric acid, which will be acting as a catalyst plus heat. Our final product is going to be an alcohol. So any one of these 2 products can be your answer. At this level, they are not strict as to which one you can give as an option for your answer. Either one of them can be marked as correct. Reaction number 2. Reaction number 3, I'm going to refer to it as halogenation. As the name suggests, I'm going to be adding a halogen to my alkene. So my reagent, I'm going to require an alkene plus a halogen. Remember, halogens are the ones in group 7, which include chlorine, bromine, and iodine. Right, for the condition for this reaction to occur, this reaction can simply occur at room temperature. There's nothing special that is required for this reaction to occur. So the final product that we expect to end up with, I'm going to phrase it as a dihalogenal alkane. Why I used the word di, it's because it's going to be having 2 halogens within the final thing. So I'm going to use butene as an example so you can see what I mean when I say that the reactions, they only occur at the carbons that are sharing the double bond. So this is my butene. I've put my double bond between the first and the second carbon to make life easy for us. And I'm going to react this with chlorine. So the two carbons that I've highlighted, that is the only position where the reaction is going to occur. This chlorine will come to that carbon and that to the other carbon. Nothing happens to the rest of the molecule. So as a result of that, the double bond breaks, and the two carbons that were sharing the double bond, they each receive a Cl, and the rest of the molecule remains the same. I'm going to include the name of this final product. But again, the emphasis of naming such compounds is going to be, I'm going to touch on it under isomerism. So this is called 1.2 dichloro because there are two chlorines within the molecule. On carbon number 1 and carbon number 2, butane. So don't worry yourself yet about the name. The fourth reaction, which is the last reaction of the alkenes that we need to be familiar with, is referred to as, again, it's an addition reaction, and again it is a halogenation reaction. But this time around, for what we are adding is either HCl or HBr or hydrogen iodide. So my reagent is going to be an alkene plus HX. My condition, this reaction does not need any special conditions. It will simply happen at room temperature. And the final product that I'm going to have is going to be a halogenoalkane. Take note of the difference. This time I didn't say dihalogenoalkane. I just said a halogenoalkane because it would just be having one halogen in the final product. Let me use a molecule like pentene. Pent means that I have 5 carbons. So now the reaction is only going to be happening at the 2 carbons that are sharing the double bond. And I'm going to use HBr, hydrogen bromide. Focus is here only. The rest of the molecule, you leave it as it is. So there are 2 possibilities. One, I can bring my H to the second carbon, and I can bring my Br to the first carbon. So the final product I will have in that case and this is going to be called 1-bromo pentane. On position number 1, I have a Br, hence the bromo. Pentane, I have 5 carbons with single bonds between them. That's one possibility. Another possibility is to swap where the hydrogen and the Br go. I can say the Br is going to go to the second carbon, the hydrogen to the first carbon. So my other possibility is having and this would be called 2-bromopentane. I have a bromine group on carbon number 2. My carbon chain has got 5 bonds with single bonds between them, indicating that it is an alkane. So that is 2-bromopentane. Any one of those two can be a final answer. So these are the 4 main reactions that alkenes undergo. We'll come across the reactions of alkenes again much later towards the end when we learn about polymerization. But here for now, as a brief intro, these are the key things we'll need to be aware of. So the next part, we're going to be looking at isomerism, isomers of alkenes and alkanes, so that we are familiar with how to name some of those products that I was forming at the end of a chemical reaction.